Okay, hello class. We are on weekly update 12. So you just finished the first half of chapter 2 of book 3.5. You're about to start the second half, and there's some really neat applications in there. I think you're going to have fun with this week's challenge problems. So last week's work, I wanted just some shout outs for some interesting things on the discussion board. That was fun to see. Brianna Pope, so Brianna with an A, really made a nice discussion of sort of the when she's doing math, that there's this like frustration and bliss. I like that word bliss, that feeling when you get it at the end. And the word I also really liked was the perseverance. I mean, I really think that is what makes someone a good mathematician. It's like you don't give up on something. It's sort of get obsessed about solving one of those problems. And that feeling of bliss is amazing. I agree, Brianna. And then Jonathan Moody, I really liked his discussion. Jonathan had something about how there are multiple ways to get to an answer. And I think a lot of people think about math, maybe one of the things they like is that it's objective, like the answer's 7. And not always is it 7 too. It's like depending on how you interpreted the description of the problem, first of all, and definitions that you used. As you get to higher and higher levels of math, like there isn't just one right answer, but supposing there was one right answer, like it's 7, well, how many different ways can you get to that 7? And that's also fascinating. I think it shows the appreciation of the different, again, that idea of a diamond has all these different faces, learning as many different faces. And that's really cool too, to see with your assignments sometimes too, how many different ways you come up with something, and totally something I never thought about is, oh wait, you can solve it that way. That's pretty cool. In fact, that just happened this week with my 105 class. Christian, really like Christian Collins' discussion about how math builds. And again, unlike other subjects, I think that is not unique, but it's something special about math. It just keeps on building. And how important it is to understand and understand the reasons behind things if you're going to be able to go higher and higher up. And another one I liked was Emma's. Emma talked about, and a couple people actually had the same thing, that math is a language. And I liked a couple words in hers about that you'll face obstacles and it's important to reroute. So those are people's individual experiences of it. And I guess what I was hoping though was to see, and I'll probably revise this language that I use next semester for the discussion problem, but how would you explain this to someone that doesn't? So we all understand that, but like the process of actually doing it, what is it like? And that was Andrew Wiles, if you read his, and then Terrence tells Andrew Wiles is like, it's really just fumbling around in a dark room for months and months and months. And then you start realizing, even though it's completely pitch black, that, okay, but that is the chair that's over there and there's the sofa, so I won't bump into them anymore. And I start recognizing these things, even though it's completely dark. And then all of a sudden, it's like turning on a light switch and boom, now you see everything. Oh yeah, actually that chair was, more of a, the type of chair that is. You have many more details and you see everything so clearly. And then you go to the next room and it's completely dark again. And that's that whole process, that turning on the light switch is like Brianna's discussion of the bliss. So I'd like to maybe get more to that next time, like what it feels like to you, that process. And the other thing, no one really commented, I hope you all read that link at the end of that one. The article was super cool about the things that, and maybe even Christian and Jonathan's point to some of the comments in their paragraphs was that in appreciating this way of learning higher level math, it actually enables you to do all these other sorts of things in life. So if you didn't check it out, please do check out that article. It's short. You guys are fast readers. Okay, next thing, samples and examples. So lots of shout outs. So let me share the screen and we'll go to these. So as usual, put these in your samples and examples section of module, what were we on? 6, I think we are. Module 6. Yeah, samples and examples, week 1. Lots of familiar names we'll see here. So Jonathan, Kyra, Sam, Ellie, Lily, Ellie, Jenna's movie, Joe T, and Rihanna P. As usual, like if you're really struggling with something, Jenna makes these short 5-6 minute videos. They're awesome. If you want to see the notes, though, like Ellie and Lily always make really nice annotations to their activities, really cool pictures. In fact, let's pull up one of those. Oh, I think this was, yeah. So if you struggle with one of these activities, I think I put maybe Jonathan and Sam's for these matches. They have really nice explanations. Oh, and Ellie's too had really nice explanations for why they chose these. Oh, and I think Lily, yeah, here then Lily explains how she sort of broke it down and, you know, decided which one was A and B. Some people just submitted with the answers, but these ones that have the notes I think are really helpful to see how your classmates think about it. And that's sort of Jonathan's point, the multiple ways of understanding something is helpful. So as you're reviewing for the final, these would be good things to look at in the samples and examples section. There was a little confusion about this problem. I noticed several students, I just wanted to talk about this. When the derivative of a space curve is all zeros, you are at one of those cusp points, right? It stalls for a second. So watch Jenna's video. I think that was really helpful, her explanation there. But at one of these cusp points, your derivative is zero. It's a non-smooth point. It's non-differentiable. That's when r prime of t equals 0, 0, 0 for a space curve, or just 0, 0 for a plane curve. But when the third component is 0 for your space curve, that's saying that just in the height direction, you've leveled off and you have a tangent. So even though this space curve is moving, I might go around like that, this would be a max, a local max in the z direction when just the third component is 0. Okay, and then, oh yeah, so here's Lily shows some visuals. Oh yeah, so this was funny. Her roommate wanted to participate. So this is, this was, what a wonderful, she calls this a cauldron of chocolate. So what a wonderful place to live in when you have cauldrons of chocolate in places. There we go. And she's showing the space curve, and then she's actually annotating the different points. And this was cool because Lily oh yeah, this made me laugh too, because I think of Lily as, right, she's our little boss. And this would be like her hype man. I just learned that phrase from watching Dave, Little Dicky. That show is really funny on FX. Okay, so this was where she was showing that at the cusp, this point she then annotated in red, she had her two different tangent vectors, one going in the forward direction, one going backwards. They don't match, so it's non-smooth. Whereas here's a place where it is smooth because those two different vectors, one in the forward direction, one in the backward direction, match. So I thought that was a really clever way of showing that. Okay. The other one I liked, I think was really nice visuals too, was Joe put, again, discussion of how he's choosing these. That's always helpful. Christian also had a nice discussion of his, breaking it down, how he chose those. Oh yeah, this was his space curve. And so the space curve here, he shows what a nice roller coaster. He'd actually like to ride it. And then the annotations. And the one I liked too for Joe's was like, yeah, here he shows that the space curve, he didn't even have to pinch it. Like this is, you're riding the roller coaster and then you have to make this abrupt change right here. And therefore you have the two different tangent vectors. Okay, and then I think one more to show. Anytime you're worried about calculations, I think Grions are the best to go for because these take a lot of load. I'm not sure why that is, but yeah, it's just so, her handwriting is beautiful, right? And just clearly step by step, everything she's trying to do, completely labeled, easy to read. So these would be really good if there's a particular section, again, super detailed. If there's a section in the journal where you're like, I couldn't do the line problems, I just really struggled with those, go back and see what Rihanna did for her homework. It's always beautiful. Okay, and then one more comment for this week's weekly update. Let's go back to the table of contents here in Oaks, and I just added a final module. You guys have been really helpful in having me prepare that material. So there's 3 sections here. So from the first one is new journal pages. So there's some tough topics that you guys had. And I noticed that that was really an assessment of my ability to explain things. And so it turns out that the topics that were difficult, I probably didn't explain well. And so I went back and added some pages. And so here's the section of pages in chapter 2. So that's what it means from book 3. All these are book 3. I haven't gotten feedback from you guys on book 3.5, but when I do, I'll add some more. So from book 3 and chapter 2, gradients were a little tough. So you'll see I've inserted some pages. So some of the pages will look familiar. Ignore the page numbers. They may not correspond now for y'all. But this page was the same gradient, and then I added some stuff, some more gradient practice problems, and then a couple activities. These were from discussions with Lane, so thank you from months ago, Lane. I think you helped me tighten this stuff up, some nice visuals. I think this will really help you guys understand gradients. And so you can go through each of these. And the journal pages are sort of all for chapter 3, but organized by chapter. So these are all chapter 2. The first thing that you'll encounter is gradients, then some tangent planes. You need help with CP, so I put a few more examples. Directional derivatives was an issue, and I added several activities here. I think you guys will find these much easier to understand now, the idea of a gradient compass. Again, thanks to Lane for that. And a directional derivative meter. So please check these out. I think they're going to go a long way in helping you study for the final. Global Extrema added a few images here that I think are going to help you guys. And I think 1 or 2 activities. Yeah, so a little quick activity, close over Joe. This will help you remember things. And then this truncated surface matching, I think this is helpful because you had trouble seeing that. A couple similar pages. Okay, another activity that I think is going to help, that you're restricting things when you're doing, it'll help you understand why you need to get those points of the boundary when you're finding global extrema. A couple of the same pages we had before. And then I think there were a few examples here. Yeah, I spread this example out and just showed what you're really getting on the boundary. When we're focusing on this triangular region, one of the boundaries is here, and then I'll check this next boundary and this third one. So when you check one boundary, I'm actually on the surface, now that you know the language, this is now a space curve. We're really just finding the local extrema, the max and min on this space curve. And that's what you're doing when you're solving this sub-problem, which is actually an R2 problem because you've restricted. Here's the next boundary, the next space curve, and then you put all those together and really in red there, and that's what you're finding when you're doing this. Okay, so then a couple other things in the final review. So those new pages, again, if you have ideas for book 3.5, I'll try to crank those out in a hurry. But we already saw this midterm calculation practice, so click on that, it'll show that same thing. Answers by Laney, thank you, Laney. I was able to check those, and excellent job on that, shows the work. And maybe someone will do the same thing for this final calculation practice. This is just practice problems of calculations that appear often on 221 final exams. There's a lot of problems here, but you know, on your final exam, details on that. So Lucas asked me some more details. So these are problems to practice, but again, there's a lot of them. There's almost 30 of them there. I can't ask you 30 calculation questions and concept questions in 2 hours that we have for our final exam. So our final exam will be on OAKS. It'll be like you take your quizzes, so it'll have some concept questions. I think I'll talk about that here. Concept questions, as usual, they're like your quizzes. They're like at the end of the chapter. They're like, get plenty of ways to practice those. And so there'll be those usual ones, multiple choice, and then there'll be calculation problems as well. And all that's in a 2-hour block. So when you go into OAKS this time for your final exam, you only have 2 hours, otherwise OAKS will cut you off at the end of that 2 hours, and you'll just, whatever you've done, you've done. If you ran out of time, that's it. And so I need to plan my exam with that in mind to make sure that time is not an issue. So what that means is all these problems here, I'm letting you work the whole thing start to finish. And again, maybe someone will crank away at some calculations and practice it, send it to me, I can check it and we'll upload it for the class. So it'll be a nice service to the class. But of course, in the 2 hours, I have to do things like, I can't ask you, let's say, for example, find the global extrema of this problem in this region. I might, because that could take just by itself 10 or 15 minutes. This one's pretty basic. This next one's maybe a little more work. But even if it's an easy one, it only takes 5 or 10 minutes. That's 5 or 10 minutes. So one thing I might do is say, assume these are the critical points for this. Now find the global extrema. So I'm giving you quite a bit of the work that would have taken a bit of the computation. An example of that might be this problem number 11 here. So check that one out, where I've kind of given you some of the work and you just have to, you're in the middle of the problem then and you have to finish it. I promise you will see number 13. There will be a problem just like that. We've hit that one a couple times. This is important, like problem foundational, I guess, for Calc 3. And most of these, you're going to go back and I think you're going to find at this point, these are pretty straightforward, pretty easy. You can make yourself a study guide you can use during that 2 hours, but Oh yeah, it is not proctored. So there will be a window, like it might open up. I think I'm gonna have it due Sunday, because we always have Wednesday and Sundays. So I'm gonna have it due on a Sunday due date, 11:59 p.m. as usual. And I think I'll open it up a couple days before that. So maybe Friday. You can take it anytime from that Friday to that Sunday. And once you start it though, you have 2 hours. So allot yourself, make sure you know, done everything you need to do. You've already gone to the bathroom, don't even take any breaks, but it will not be proctored. We don't all need to be on Zoom or something like that. So you'll do it at your own pace, at your own time within that 2 hours. And then at the end of it, so Oaks, again, you're being clicking on those true, false, multiple choice. This is the right answer. You have to submit your work. And that is the thing that is being assessed by mathematics faculty, the department. And so we are going to use that. Some of the problems you won't need to show work, again, the concept questions, but there are some that'll be very specific, show your work, and you're going to submit that as usual in a Dropbox, one PDF file, and you'll have within 10 minutes to submit that from when Oaks turns off at the 2 hour mark. You'll have another little 10 minutes to go ahead and get that Dropbox entered in the Dropbox. The reason, and that is a departmental policy, so we have a timestamp for when Oaks ended the final exam for you, and then you have that small windows to submit your work to make sure, again, that you're not running around checking it with, you know, a math major, having someone do your work for you. And we're making sure that you're not using tech tools. There will be some problems where I will say use a tech tool. I'll say, you know, set up the integral, and now it's such a nasty integral. I just want to make sure you've modeled it correctly and then use a tech tool. So there'll be very clear instructions on your final exam, but these are the type of calculation problems you'll see. And you'll see that that covers everything that we've done at this point. Let's see if have I hit everything. I think that was, let's go back. Yeah, I think that's everything I want to say. So have fun this week. Again, I think you're going to enjoy the challenge problems, or some particularly interesting ones to work with your group. Y'all are doing great. Just keep it going. Only a couple more weeks. We're almost there.